Welcome to the Pod-Key summary of Compose Advanced Graphics Effects with SwiftUI from WWDC 2026. Today's thread is a really useful way to think about SwiftUI, not as a pile of fancy tricks, but as a pipeline. The big idea is that a lot of the so-called advanced UI work comes from connecting simple pieces. Well, especially when you mix SwiftUI's shader effects, a shared time source, and some precise layout tools like alignment guides. And once you see it that way, animated backgrounds, sync transcript movement, and custom overlays start to feel a lot less mysterious. The framing here is simple and honestly pretty freeing. Every SwiftUI modifier or API can be treated like a pipe. Something goes in, that pipe transforms it, and then passes it downstream to the next stage. So the complexity usually isn't hiding inside one magical effect. It comes from how those pipes are connected, branched, and merged to build the final result. That's a nice mental model, because it turns advanced visual design into a composition problem instead of a wizard problem. SwiftUI gives you three main shader effect APIs: color effect, distortion effect, and layer effect. It sounds similar at first, but they do different jobs, and they take different kinds of inputs. Color effect is for changing the color of pixels. Distortion effect is for moving pixels around geometrically, which makes it a natural first stop when you want some kind of positional shift. And layer effect is the more flexible one, because it lets you sample nearby pixels from the rendered layer. That extra sampling ability matters a lot, because once you can look around the current pixel, you can build things like blur, warping, and more custom image behavior. In the example, distortion effect makes sense for a simple offset, but layer effect wins in the end, because it gives more room to do something richer. This is one of those subtle choices that changes the whole ceiling of the effect. If all you need is a straightforward positional nudge, distortion effect can do the job cleanly. But if you want the image to feel alive, soft, smeared, or fluid in a more organic way, sampling neighboring pixels is a huge upgrade. That's why layer effect becomes the better fit for the animated background here. It's less about choosing the most advanced sounding API, and more about choosing the pipe that matches the kind of transformation you actually need. The visual trick at the center of the background is domain warping, and it's a good one. The shader samples a pre-computed noise texture once to get an initial offset, then samples that same texture again at the offset position. That second lookup makes the motion less uniform and a lot more natural looking. Instead of everything drifting with one predictable push, you get these organic flowing blobs and irregular distortions. It's basically layered noise, creating richer movement than a single offset ever could. And visually, that tends to read as more alive and less like the background is just politely vibrating. One important catch is that shaders are stateless. They don't remember what happened on the previous frame, so they can't animate themselves in the way SwiftUI views often seem to. That's where timeline view comes in. By feeding a changing timestamp into the shader on every frame, SwiftUI gives the shader the one thing it needs to produce motion, a time value that keeps moving forward. So the animation isn't coming from the shader storing history. It's coming from SwiftUI repeatedly supplying fresh input. This is also a nice contrast with regular SwiftUI animation. Built-in SwiftUI animations usually happen through state changes and transaction semantics. You change some state, SwiftUI interpolates, and the framework handles the in-between motion. Shaders don't work like that. They need explicit parameters, and for continuous motion, that usually means explicit time. So if you're trying to animate shader effects inside a declarative app, timeline view is not some extra flourish. It's basically the bridge that makes the whole thing possible. A detail I really like here is that the same time pipe is reused in more than one place. That timestamp doesn't just animate the noise-driven background. It also drives the transcript scrolling. Using one shared temporal source keeps those pieces in sync and reinforces the whole pipeline mindset. Time becomes just another input flowing through the system, not some separate animation island off to the side. The transcript overlay uses another very SwiftUI-ish trick: custom alignment guides. The presenter treats alignment as a pinpoint, which is a really handy way to think about it. By redefining a subview's bottom alignment to actually use its top edge, a timestamp label can pin exactly to the edge of its container. That means no manual offset math and no fussy trial and error positioning. The timestamp appears only for the active transcript line, but the overall layout stays stable. So you get that floating label effect without the interface jittering around, which is always appreciated by people who enjoy their UI calm and house-trained. Stepping back, the bigger lesson is the creative process behind the effect. Start with the design, break it into layers, figure out what each layer needs to do, and then map each one to the right SwiftUI pipe. Maybe one pipe handles timing, another handles layout, another handles pixel sampling, and another handles the final composition. Once those pieces are in place, the advanced look is really the result of composition. That same architecture can support plenty of variations too. The speaker points out that you could swap in other inputs like gyroscope data, or try a completely different shader idea like ripples, while keeping the same basic pipeline structure. So the takeaway isn't just one cool background. It's a reusable way of building custom UI effects that stays understandable as it gets more ambitious. That's the part I like most about this approach. It makes the work feel modular, not mystical. A few well-chosen pipes, a good time source, and some careful layout can get you surprisingly far. And once you start seeing SwiftUI that way, you may begin mentally piping everything, which is probably fine, until you start describing your coffee routine as a render pass. This episode was generated by Podkey. Create your own at podkey.fm.